So in this video, we're going to talk a little bit about transesterification, which is a method to take an ester and actually convert it into another ester. So a simple way to think about this is I'll draw some really simple esters here. So these are all equilibrium reactions, of course. But if I want to change this even to just from the methyl ester, the methyl ester to the ethyl ester, the way I could do that, I would need a little bit of acid catalyst, and then if I want to shift the equilibrium to lean towards this way, right? So if I wanted to move that way, and so if I want to shift way this way and make this one a little bit smaller, I would add in as my solvent, right, ethanol in this case, because I want to exchange out this part with my solvent, so I'll shift equilibrium this way. Solvent would be basically the ACE principle. A lot of this around, it'll react with that, it'll contribute to that. So how does this mechanism work? Similar to what we've seen before. First step is in an acid catalyzed process would be protonation. So we protonate our ester, which makes it a bit more better electrophile, makes the carbon in the carbonyl group that much more electrophilic. Solvent, because there's a lot around, will react with that. So we had our protonation, now we got our addition step. OH, got a good old tetrahedral intermediate. At this point we need to do a proton transfer, because we want to get rid of this piece, is what's going to fall off. But right now this is the best leaving group. So to do that, simply move the hydrogen around, balancing our charges. Very good. Last step can be that deprotonation there and elimination at the same time. So we got that deprotonation, elimination all at once. This becomes our new H+, new pi bond right here, new ester, and we also make, of course, the other byproduct here is actually the other alcohol. Right, so that's the transesterification, way to convert from ester to ester in acidic conditions. So let's take a look in a different situation now. What if we want to do this in acidic conditions as we did it up here, which we see it a lot of times? What if we want to actually do it in basic conditions? How would this look? Right, so in basic conditions, to get this to work, we can't use the catalyst actually. We're going to actually need to fully replace, or a solvent. So we actually need to use whatever we want to substitute with, right? We need to use probably an excess of this, at least one equivalent, but an excess will help drive the reaction right this way. What else we're going to make here to balance our charge? We're still going to make, right, this other group that falls off, which comes from here. Probably use a organic solvent here. I'm not really going to worry too much about that, but this one's a little simpler mechanism, like as basic mechanisms are. We have the first step is an addition step. From the addition step, we get a tetrahedral intermediate. We balance our charge. Right, and because we maybe have excess of this, we'll get to this intermediate a lot, and eventually we'll, again, excess of one reagent shifts towards products. So this excess of one star material shifts towards the products. And what's going to happen, this will come down, that'll kick out, so that elimination step there, and that gets us to the two products. So this is a basic transesterification, again, going from ester to ester. So these are just the word, transesterification is just a way to say ester to ester in both acidic and basic conditions. Usually it won't work in neutral. You need some sort of reactive species, acid or base, to make this work.